Hi everyone, in this video we are going to see the how to evaluate the energy and power of a discrete time signal, and based on that we are going to conclude whether the given signal is an energy signal or power signal or neither energy nor power. Okay. Energy and power of a discrete time signal. Let us take here the discrete time signal x of n. The energy of a discrete time signal can be evaluated as the summation n is equal to minus infinity to plus infinity mod x of n whole square. And the power of a discrete time signal can be evaluated as limit capital N tends to infinity 1 by 2n plus 1 summation n from minus n to plus n mod x of n whole square. So, based on this you are evaluating the energy and the power of a discrete time signal. So, if a discrete time signal is said to be energy signal if the energy is finite value, the energy is finite value and the power is 0. Okay, for a discrete time signal, if the energy is finite and the power is 0, you can call it as the signal is energy signal. Energy signal. Yes, the discrete time signal having the energy is infinite, and the power is finite, then the signal is called it is power signal. Then the signal is called it is power signal. If the two conditions fails, if the above two conditions fails, then the signal is neither energy nor power. Okay. So, to say the signal is the energy signal or the power signal, so you must evaluate the both energy and the power of a discrete time signal. If the energy is finite and the power is 0, then the signal is said to be energy signal. If the energy is infinity and the power is finite, then the signal is said to be power signal. If the two conditions fails, then the signal is said to be neither energy nor power. Let us see one example. Okay. Let's take the discrete time signal x of n is equal to 1 by 2 whole power n into u of n. Okay. For that, the energy of a signal is summation n from 0 to infinity 1 by 2 whole power 2n. Okay. This can be written as summation n from 0 to infinity 1 by 4 whole power n. Its value is, this is in the form of summation n from 0 to infinity a power n, where this a value is less than 1. So, it is 1 by 1 minus a, which is 1 by 4. So, the value is 4 by 3. So, the energy of the given discrete time signal is 4 by 3. Similarly, calculate the power. The power is limit n tends to infinity 1 by 2n plus 1 summation n from 0 to capital N. Directly I am writing it is a 1 by 4 whole power small n. So, it is the limit capital N tends to infinity 1 by 2n plus 1, this value is 1 minus 1 by 4 whole power capital N plus 1 divided by 1 minus 1 by 4. When you are applying the limit, this whole value is a positive and this value is 1 by infinity, the value is 0. Okay. Now, here for the given discrete time signal, x of n, how the energy is finite and the power is 0, therefore, the given signal is energy signal. Given signal is energy signal. Okay. Let's take the one more, another example. Okay. Let us take here the discrete time signal x of n is e power j 2 pi by 5 n plus pi by 6. The complex exponential functions, so the energy is E is equal to summation n from minus infinity to plus infinity mod e power j 2 pi by 5 n plus pi by 6 mod square. So, mod x of n whole square. So, let us see here This function is simply in the form of e power j theta mod square. So, mod square is nothing but the square root of real term square plus imaginary. E power j theta is nothing but cos theta plus j sin theta whole square, which is square root of cos square theta plus sin square theta. This is the mod. For that you are taking square. So, the value is 1. So, this mod e power j 2 pi by 5 n plus pi by 6 whole square, this value is 1. So, the summation n from minus infinity to plus infinity 1. So, here we are adding the 1 for infinity times, the result is infinity. So, the energy of a given discrete time signal is infinity. Now, try to calculate the power. Power is limit n tends to infinity 1 by 2n plus 1 summation n from minus n to plus n. This mod value directly I am writing it is 1. So, which is the limit n tends to infinity 1 by 2n plus 1. So, here you are adding n for minus n to plus n, that is 2n plus 1 times. So, these 2 will get cancelled. Now, the value is 1. Now, here let us see for the given discrete time signal, the energy is infinity and the power is finite. So, therefore, the given signal is power signal. Power signal. Okay. For the same two examples, the two discrete time signals, we will try to develop the MATLAB code. So, how you can say the given signal is energy signal or power signal or neither energy nor power. That means, how we are going to evaluate the energy of a discrete time signal and the power of a discrete time signal using MATLAB. Okay. So, in these two cases, let us see in these two cases, to evaluate the energy accurately, you need to consider the signal in the entire interval, in the infinity duration. Okay. For that, see the MATLAB code. Okay. For that reason, I am defining the variable, the time variable as a symbolic object, so that you can evaluate or you can define the small n without defining its range, so that you can evaluate the your function in the entire interval. Okay. Now, my function x, the first case it is 1 divided by 2 whole power n. Okay. Now, I am evaluating the energy E is equal to, what is the E is equal to? The first one, that is summation n from 0 to, for the same thing I am going to write the MATLAB program, that is summation n from 0 to infinity 1 by 2 whole power 2 n, which symbolic summation. Okay, is a keyword. This I will explain here. So, this is our example, n from 0 to infinity 1 by 2 whole power 2 n, this is your energy. Okay. The MATLAB, for this we have the one keyword which is symbolic summation. Okay. That means it gives the summation symbol. So, here you need to pass the 3 argument for which function you are taking the summation and what is the summation variable, and what is the lower limit and what is the upper limit. So, the input argument for the symbolic summation is for which function you are taking that, your function, and what is the summation variable, and what is the lower limit, and what is the upper limit. Okay. Here our function is x and you are taking the square for that, x square, and the summation variable is n, and the lower limit is 0 and upper limit is infinity. Okay. Then after writing this summation, then simplify this. So, whatever the summation you are written here, this whole thing will be simplified. Okay, you will get the energy value is 4 by 3. Okay. Similarly, we will try to write the code for power. The P is equal to the same, the symbolic summation of the function is x square and the summation variable is n and the lower limit is 0, the lower limit is 0 and upper limit is capital N. So, upper limit is capital N. Okay. Here we are not defining the capital N, so that is reason I am again defining the capital N is also as a symbolic object. Now, after writing this, let's see the power one, power equation. So, we written the code for this part, okay. Then that whole thing is divided by 1 by 2n plus 1. So, this is divided by 2 into capital N plus 1. Okay. This part is completed. Then for the whole this you are applying the limit, and the limit variable is capital N and the limit value is infinity. Okay. So, for this whole we are applying the limit of, this is your function and the variable is capital N and the value is infinity. Okay. Now, I written the code for the whole part and then simplify the whole thing by the keyword simplify. By the keyword simplify. Okay. Now, you are evaluated the energy and the power of a discrete time signal, then check the condition. Okay. If the energy of the signal is finite, that I am indicating by the not is equal to infinity, and the power is equal to 0, then the given signal is energy signal. Given signal is energy signal. In case if the energy is infinite and the power is finite value, that means is not equal to infinity, then the given signal is power signal. Okay. If the two conditions are fails, then else just display that the given statement is, or the given signal is neither energy nor power, then end the statement. Okay. Now, run the code. As I am saying somewhere in the so, given signal is an energy signal, and you can see the how much energy is a 4 by 3 and the power value is 0 and the signal is energy signal, that you can see here. We got the power is 0 and energy is 4 by 3. Okay. Now, similarly, we will check for the second signal. Our second signal, that is e power j 2 pi by 5 n plus pi by 6. Okay. Okay. Now, I will see the second one. Signal is x is equal to e power, that is exp of j into the signal is 2 pi by 5 n into pi into n by 5 plus pi by 6. Okay. Now, this is your signal. The same way, here you are taking the mod x of square, that is, since it is a complex function, the mod is abs of x absolute value, and the limits are from minus infinity to plus infinity. So, here, so minus inf2 plus inf, minus inf2 plus inf. Similarly, while evaluating the power, so we need to calculate it here. ABS of x, which is nothing but the absolute value of x. Since our signal is a complex exponential, okay, there is a change of x square and mod x square. Okay. The previous case where our signal is a real function, so there is no change in the square and mod square, and the limits are from minus n to plus n. Limits are from minus n to plus n. These are the two modifications I am doing, okay, which is one is the absolute ABS of x whole square and our limits from minus infinity to plus infinity. Okay. The remaining is as it is. Now try to run the program. Okay. Now you can see the values. Our energy is infinity and the power is 1, therefore the given signal is power signal, like this. So like this you can evaluate the energy and the power of any discrete time signal using MATLAB. I hope you like this video. Thank you.